Now our next question is question number 34. Butane dione CH3COCOCH3, the yellow liquid. How does butane dione react to 4-dinitrophenyl hydrazine reagent and Fallings reagent? Alright, so in this question we are provided this compound and we have to check which of these two reagents will give positive test with this compound. I have to make a simple display structure of this molecule to make it easier for you to understand. This compound is basically composed of 4 carbon atoms, and there is a dione here. This dione means there are 2 carbonyl groups on it. There are 2 times of the carbonyl groups on it because it comes from the word ketone. The name of functional group ketone is stated as on. So we will have 2 dione functional groups on it. Why I'm placing them over here? Why not on the extreme carbon atoms? The reason is that if I put over here, then I should need another carbon over here, because the functional group of the ketone says it is present between 2 alkyl radicals, and this must be any methyl, ethyl or other carbon chain. So it can only be present within the these 2 carbon atoms in the butane structure. So I have drawn the structure of butane dione. Now we will check what is a positive test or negative test of this 2,4-D and pH. It is 2,4-D and pH. We have read in our literature that 2,4-D and pH can give test with the aldehyde and ketone functional groups. It can give you positive test with both, with aldehyde as well as ketone. So here we have the ketone functional group over here as well, which means it will give you positive test. That is right. Now about the Fallings reagent. The Fallings reagent can give test only with the aldehyde, because we have seen in the literature. Here in my notes of AS chemistry, you can find under the Fallings solution reagent reaction that this compound can react when bound with the aldehyde. It oxidizes aldehyde to the carboxylate ion, a salt of the carboxylic acid, and it does not give any reaction with the ketones. It is mentioned here that it does not give reaction with the ketones. So considering that, we can say that the given compound in our question will give test, will not give test with the Fallings. It is shown here that just like Tollens, the Fallings solution does not also give the test. So coming back to the question, we will say that the Fallings compound reagent will not give test with the ketone. It can give test with the aldehyde only. So the column with negative will be the right one. So here the right option becomes option number B. Now the next question, number 35. Which substance react with ethanoic acid to give the organic product with the highest MR? So we are provided with the following options, and these compound must react with the ethanoic acid. The ethanoic acid, as you all know, has this formula CH3COOH. Now this ethanoic acid must react with all these 4 given compounds separately. And after that we need to check the MR values of all the products we get, especially for the organic products, not all the products but only the major organic product which will be produced as a result of the reaction between these reagents and ethanoic acid. So let's start with the option A, which states it is the lithium aluminum hydride LiAlH4. Now this is, as you know, is a reducing agent. This reducing agent can reduce the ethanoic acid. The ethanoic acid, when reacts with this reducing agent, it will first convert into the aldehyde compound CH3CHO and further it reduces to the CH3 into the ethanol, CH3CH2OH. Now if you find the MR values, then you find out that the MR value of this aldehyde will come out to be 44. On the other hand, the MR value of this ethanol will be 46 because it has two more hydrogen atoms than aldehyde. So we have found the values of these. Now we'll check with the magnesium. You cannot find the answer until you will apply all these reactions separately, because you need to find the MR values of all the reactions. Only then you will see which one has the highest MR value. So with magnesium, the reaction is just like with the calcium. In my notes, you can see the reaction of the carboxylic acid with metals, and you can see that when it reacts with the magnesium, it will produce this compound. So the compound will be CH3COO. There will be two molecules of this compound bonded with the magnesium. Now the MR value for this compound will be, it is equal to 118. You can check this on your calculator. Now with potassium carbonate. With the potassium carbonate, the product will be CH3COOK. The salt, there is just one potassium bonded with the ethanoic acid, with the ethanol acid, and then its MR value is equivalent to 98. Then at the end, propanol. Propanol is actually, we know, is an alcohol with the hydroxyl group on the second carbon. So the reaction between alcohol and the carboxylic acid is a esterification reaction to form the ester. So in this compound D, we will get the ester compound. Just one more thing, in the B option we also get the hydrogen gas, but that is not included as our product because it is not an organic product. We need to check the organic product. Same goes with the option C, in which we also got water plus carbon dioxide, but these two are not the organic products, so we do not count them. Now for option D, we need to find the compound, the structure of the ester which will be obtained. So I'm going to draw the structure of the ester. This part will be from the ethanoic acid, and then we need to connect it with this alcohol. So as we know that this alcohol is present on the second carbon atom, which means this carbon will have CH3 on this side and CH3 over here. Now this is the ester which is obtained by the reaction between the ethanoic acid. This part comes from the ethanoic acid, and the other part comes from the alcoholic part. This is the alcoholic part, so we got the ester. Now after calculating all the atoms masses, you will find out the MR value of this compound will be 102. So you have got MR values of all the products, the organic products of all these reactions. So from these you can see clearly that the highest MR value goes for the option B, in which MR value is 118. So option B is the right answer. Now next question, number 36. Sample of propyl ethanoate is hydrolyzed with aqueous sodium hydroxide under flux, and the two products obtained are separated purified weight. What is the total mass of the products? Out of the total mass of the product, what is the percentage by mass of each product? So basically in this question we need to react this propyl ethanoate with the NaOH under flux, and as a result of this reaction we will get products. We have to check what is the percentage mass of each product out of the total mass. So basically we require to have a reaction here, propyl ethanoate. It is an ester, and I need to draw the structure of this propyl ethanoate. The first part belongs to the alcoholic part, so CH3, CH2, CH2. This becomes 3 carbon atom, propyl, and then its alcoholic part is bonded with the carboxylic part of the ester, which is in this case is 2 carbon containing compound, that is ethanoate. So I will have this structure. Now this is the structure of the propyl ethanoate. Now it will react with the aqueous sodium hydroxide. So it reacts with NaOH, and we know that this is a hydrolysis reaction, and as a result of this hydrolysis reaction, this compound will break down into 2 parts. One of the parts will be alcoholic part, and the other one will be carboxylic part. So the alcoholic part will become CH3, CH2, CH2OH. This is now the propanol here, and then the other product in this case will be the salt of this sodium, carboxylic salt of this sodium, because we are using alkaline NaOH. If we have used the HCl, then the product would have been the carboxylic acid. So here we are using sodium hydroxide, so the product will become CH3C carbonyl group and ONA. This is the salt of the carboxylic acid. In this case, it is the sodium ethanoate. So we need to calculate the MR values. The MR values of this compound, the ethanol, will come out to be 60 gram per mole. This is the value of this ethanol, and for the sodium salt of the ethanoic acid will be 82. You can calculate on your calculator. Now we need to add them together. 60 plus 82, it will give you 142. Now that's the mass of both products combined. Since we have to find out the percentage by mass of each product, then the total mass will be 142. Now we'll check the percentage by mass. So percentage by mass of each will be 60 divided by 142. It will be equivalent to 42.23%, which is just rounded to 42.3%. So that's the answer from one of the options. And then for the other part is 82 divided by 142, and its answer, like, we are also multiplied with the 100 because we had to calculate the percentage mass. So it will give you 57.7. so it is an option, one of these options. So that's why the correct option becomes option number C. And this question was basically repeated from the past years, but I have solved the question by myself. Now the next question, number 37, it is repeated 2 times in the previous years. Question 37 says which statement about PVC is correct? Combustion product PVC are very alkaline and harmful to breathe in. So to have the clear idea of this statement, we need to have a thorough reading of the literature. So let me show you my notes. Now these are my notes of the AS chemistry, and under the topic of the PVC, polyvinyl chloride, we can find the disposal of polyalkene plastics, and under this comes the incineration, burning plastic waste. Within this incineration, we can find that incomplete if PVC waste is burned, acidic HCl gas is given off, as well as toxic compounds called dioxins. So what we see here, that when PVC is burned, we are getting acidic HCl gas. However, in our question it says alkaline gas, so this part is incorrect. whereas the other part, harmful to breathe in, is correct because it is a dioxin, so we cannot breathe. That is harmful. So this option A becomes incorrect. Now the part C says molecules of PVC are unsaturated. PVC means it is saying about the polymer, not the monomer. It is a polymer. So for polymer we need to go back to the structure. So this is a structure of the PVC. So in this structure it says that it should be unsaturated. So unsaturated means should have carbon-carbon double bond. However, in PVC we can find that there is not a single carbon-carbon single bond here. All of them are basically single bonds. They are all saturated. So this becomes incorrect statement. These are not saturated, these are not unsaturated. And D option say repeat unit PVC is CH2CCl2. So we can see from here that the repeat unit of this is this one, and within this structure we can say it does not contain two chlorine atoms. There is just one chlorine atom. However, in our question they said two chlorine atom, which is incorrect. Although there are two carbon atoms and there are three hydrogen atoms, so this whole is incorrect repeat unit. And B option says the empirical formula of PVC is the same as the empirical formula of the monomer. So yes, that is correct, because the empirical formula of the monomer comes out to be C3H2H3Cl. That's the empirical formula of the monomer, and same goes with the polymer of this vinyl chloride. Even here you find that at the end you will get the same molecular formula of the whole polymer, since the bond was broken from here. So when it was broken, we got one bond over here and one bond on this carbon. So they are just the breakage of the double bond. However, the atoms are still the same. So empirical formula of PVC and monomer will remain the same. So that's why the option B is a correct option. Now question number 38. Compound Q reacts separately with HCN and NaBH4 under suitable conditions. Both reactions produce an organic product with a chiral center. What is compound Q? So here we are given the four options, and all these four options represent the compound Q. Now this compound Q must react with the HCN separately and NaBH4 separately, and out of the products obtained we need to find the chiral center in which both the products must contain the chiral center. So here we need to separately discuss all these reactions. So starting from the first, I will label HCN as A and NaBH4 as B to make it easier. Now the butanol, as we know, its structure is carbon, four carbon atoms along with one carbonyl group, because it belongs to ketone. So when it reacts with HCN, A is representing HCN. When it reacts with HCN, then this carbonyl group will be converted into the alcoholic group, and the CN group will be bonded to its other end, and then it will continue with the butane. So the four carbon atoms are intact like this, but OH is present here and CN is present here. Now this is the product of this reaction, and for the NaBH4, first of all we need to find does it contain chiral center, only then we'll proceed. So you can find that here the chiral center is present over here. This is chiral center because we can see that this carbon is basically bonded with four different groups of atoms: methyl, alcoholic, CN, and this is a different group. This is the ethyl group. So yes, it contains the chiral center. Now we will check with the other reactant, which is NaBH4. So I'm putting comma over here to separate it, and now it will react with the compound B, which is NaBH4 here, and NaBH4, as we know, is a reducing agent. Now as a result of this reduction, this ketone will be converted into the secondary alcoholic compound. Now this is a secondary alcohol. So in this case, the structure has like this one. Now we need to find the chiral center. So the chiral center is present here because we know that this is an alcoholic group, this is a methyl group, this is hydrogen, and this whole is the ethyl group. So we can see clearly that both these products contain the chiral center. So in this case, the right option becomes A. We can also check with the other compounds as well, just for the information. With the ethanol, the ethanol has the structure CH3 C carbonyl group with a hydrogen. Now when it reacts with the HCN, it will convert into CH3. The carbonyl group will convert into the alcoholic group, and the hydrogen will be there along with the CN. Now in this case, the chiral center is present here. We'll get carbon center here because OH is present here, hydrogen is there, CN and methyl, all these are different groups. And when it reacts with NaBH4, which is a reducing agent, then as a result of this reaction, this aldehyde will convert into the alcohol CH3 CH2 OH. Now this does not contain chiral because this carbon is bonded with two hydrogen atoms, so there is no chiral center. And with propanol, the structure is propanol is CH3 CH2 carbonyl group and hydrogen. When it is reacted with the HCN, it will convert into CH3 CH2, and this carbonyl group will become the alcohol group. Hydrogen will be there along with CN. Now on this carbon, we again get a chiral center. Chiral center is present here because it has OH group, hydrogen, CN, and ethyl group. And with the reaction with NaBH4, it will convert into the alcohol CH3 CH2 CH2OH. So just like in the previous case, there is no chiral center. And with propanol, the propanol will give you the structure of propanol is CH3 C carbonyl group and CH3. When it reacts with the HCN, you will get CH3, and the carbonyl group will convert into the alcohol group, and there will be CN on the other side and then CH3. Now in this case, there is no chiral center because this carbon is bonded with two methyl groups on the sides, so there will be no chiral center. And with the B, which is the reducing agent, this will convert this ketone will convert into the secondary alcohol. So again, in this case, you will not find any chiral center because this central carbon is bonded with two methyl groups, so there is no chiral center. So that's why option is the right one. Now moving to the next question, number 39. Compound X has following properties. X has 0.2 mole. When it completely reacts, it produces 14.4 dm³ of the carbon dioxide, and X reacts with 2,4-DNPH to give orange crystalline product, and X does not give product with the alkaline isotope. So we need to find which of these is the compound X. We can now do some checking to find the identity of the compound X. For this purpose, let's check point number 2 first. X reacts with 2,4-DNPH, and we know that 2,4-DNPH out of these options only those compounds can give the positive test which are either aldehyde or ketones. So from these given options A, B, C, D, we can check that option A contains ketone, so A will give this test. Option B contains propanol, so yes, B can give this test. Option C is an alcohol, so it cannot give you the test. And option D is again aldehyde, so yes, it can give you the test. So C is eliminated. And third point says X does not give a yellow precipitate with alkaline I2. So in this case, we will say that we need this compound to give you the test. CH3 C double bonded O. This should be the part present in the compound to give the test with the alkaline I2. So from here we can see that the propanol, which has this structure CH3 CH2 CHO, this does not contain this part which is required, so D is eliminated. So we are left with option A and B, which means we now have to do some calculation on these two compound A and B. So for this purpose we will react first of all A with the compound, we will first of all react A with the oxygen to make the reaction. So hexane 3-on has a structure. To make it simple, it has carbonyl group on carbon number 3, and we have got this structure. It will react with oxygen O2, and the product obtained will be carbon dioxide plus water. But to make it easier, I will write the molecular formula of this structure. The molecular formula becomes C6H12 and O. This is the molecular formula of this hexane 3-on. When it reacts, let me draw separately the display formula. When it reacts, the oxygen will get carbon. Now we need to balance it. I have 6 carbon atoms here. I will multiply 6 over here. Now you have 6 carbon atoms. Now check the hydrogens. There are 2 hydrogens here, so I'll multiply with 6 over here. Now hydrogens are balanced. Now check the oxygen. The oxygen in the right side are 12 plus 6 is equal to 18. There are 18 oxygen on the right side. On the left side we have 3 oxygen atoms. So what I will do, I will multiply this oxygen molecule with 17 over 2. This is the for the O2 molecule, so I will get 2 will cancel 2, so I will get 18 oxygen on the left side. So this is the reaction for the combustion of hexane 3-on. Now I will do the calculations. I'm already given the 0.2 mole of the X, so I need to check which of the reaction will give me 14.4 dm cube of the carbon dioxide. For this purpose I need to find the number of moles of carbon dioxide using this stoichiometry equation. So let's do the calculation. Hexane is taken as ratio with carbon dioxide. Now we can see here hexane has 1 mole, so 1 mole of hexane will produce carbon dioxide as 6 moles, and the mole of the X, which is hexane in this case, has 0.2 mole. So it means we need to find the value moles of the carbon dioxide. So the moles of carbon dioxide will come out to be 6 times 0.2, it is 1.2 mole of carbon dioxide. Now we can now check the volume produced. So 1.2 moles times 24 dm cube. Why? Because the condition provided is room temp conditions, which means 24 dm cube. So when I will multiply this, I will get 28.8 dm cube. Now this is the volume of the carbon dioxide produced as a result of this reaction, which means this option is incorrect because I needed 14.4 dm cube, which is not produced here. So this A option becomes incorrect. Now let's check the calculation with propanol. The propanol has this structure CH3 CH2 COH. Now this must react with the oxygen, so I will simplify it by considering its molecular formula. Its molecular formula will come out to be C3H6O. Now it will react with the oxygen gas to make carbon dioxide and water. Now again we need to balance it. There will be 3 molecules of carbon dioxide, and hydrogen will be water will be multiplied with 3 to make hydrogen balance. Now there are 6 plus 3 oxygens on the right side. So for this purpose I will multiply oxygen with 4. Now I have got it balanced. Now I will check the ratios. The propanol ratio carbon dioxide, there is 1 mole of propanol and there are 3 moles of the carbon dioxide, and according to the statement I am given 0.2 mole of this X compound, which in this case is the propanol, and I have X moles of the carbon dioxide. So I will check X value. It will become, by cross multiplying, X will become 3 times 0.2 and it will be 0.6. Now I will multiply 0.6 mole is a mole produced for carbon dioxide. Now I will convert into the volume. 0.6 into 24 dm cube, and when you multiply it you will get 14.4 dm cube. Now this is the volume of the carbon dioxide produced when 0.6 and multiply with 24 dm cube, and this matches with this 14.4 dm cube. So that's why the correct option becomes B. Now the last question, number 40. A sample of butanoic acid is analyzed using infrared spectroscopy. The infrared spectrum shows a broad peak in the range 2500 to 3000 cm per cm. We are given this table of the infrared spectroscopy. Then we have to find which bond is responsible for this peak. Okay, so for this question we are given the peak at this range 25 to 3000 per cm, which means we have to match this value with the already given values in the table. So if we check it, this value matches with this one, 2500 to 3000 per cm, and it is against the presence of the OH group. Now this OH group can be present in both hydroxyl compound as well as carboxyl compounds, and this compound has the carboxylic group here, which means it is present in the carboxylic group. And it says which bond is present for this peak. So it is the OH group, and OH group is present in the carboxylic. So this is the OH group which is giving you the peak of 2500 to 3000 per cm. That's why the right option becomes D. Now we have completed this paper of variant 3rd, paper 1, May-June 2024. I hope all of you have clearly understood all the parts, all the questions of this paper. If you have any queries, you can leave the comments below, or you can reach me out on my WhatsApp number as shown on the screen. Now I will come back with another past paper solution of your demand or on my own will. So take care and goodbye everyone. Don't forget to subscribe my channel and like my videos, and share with the friends and students in your circle. Thank you.